Hi everyone, welcome back to Pinnacle Education. Today we'll be answering Pearson Edexcel International GCSE, June 2024, Further Pure Mathematics, Paper 2. Let's begin. Question 1. We are given a function, which is a cubic function, and there is an unknown a in it, where a is a constant. Given that 3x minus 2 is a factor of this function, question A says, show that the constant a is equal to 21. So we can use the factor theorem here. So according to the factor theorem, if we replace 2 over 3 in place of x, as in if we do f of 2 over 3, this should be equal to 0 according to the factor theorem. So how do we come up with 2 over 3? If 3x minus 2 is a factor, what we do is we just equate this to 0 and find what x would be equal to. So x would become 2 over 3, and this is the value 2 over 3 that we substitute here, and that should be equal to 0. So let's continue with this. So if we substitute 2 over 3 in place of x in the function, that should be equal to 0. So let's do that. So this becomes 6 times 2 over 3 cubed minus 13 times 2 over 3 squared plus a times 2 over 3 minus 10 equals 0. Let's simplify these. Let's use a calculator. So when I solve the first term, the second term, and the fourth term together, I get minus 14. And then this third term is just going to be 2 over 3a. So plus 2 over 3a, and this is equal to 0. And then we can move minus 14 to the other side. So 2 over 3a is equal to 14. A is equal to, we can move 2 over 3 to the other side. On the other side, it'll be 3 over 2. And this becomes, we can divide 14 by 2, and that becomes 7. And 7 3s are 21. And we've shown that a is equal to 21. That is question A. Question B, hence, show algebraically that the curve y equals f of x has only one intersection with the x-axis. So we have the curve equation. Let's rewrite the curve equation. F of x is equal to 6x cubed minus 13x squared plus 21x minus 10. And when this curve intersects with the x-axis, there's only one intersection point. That is what we have to show. So when this curve intersects with the x-axis, what do we do? So we can say for roots, to calculate roots or x-intercepts, we have to equate the curve equation, the cut function, to the x-axis equation, which is y equals 0. So f of x is equal to 0, and we'll be solving 6x cubed minus 13x squared plus 21x minus 10 equal to 0 equation. We'll be solving this equation to find the x-coordinates of all the intersection points between the curve and the x-axis. But we don't need to find all the roots, or we don't need to find the x-coordinates of the roots. We just need to show that there's only one intersection between the curve and the x-axis. So how do we do that? Okay, first of all, to solve this equation, the first thing we do is we factorize the cubic equation, and then we'll solve. So let's do that. Let's try and factorize the cubic. We already know a factor. 3x minus 2 is a factor, so we can say 3x minus 2 is a factor. So if we divide this function, this cubic function, with this factor, we'll get a quadratic, and then we can solve further from there. So let's divide the cubic function with this factor. 3x minus 2 divides 6x cubed minus 13x squared plus 21x minus 10. Okay, so let's start with 3x. So 3x times how many will give us 6x cubed? So 3 times 2 and x times x squared will give us 6x cubed. What about minus 2? So minus 2 times 2x squared would be minus 4x squared. Minus 4x squared. Okay, so we subtract. When we subtract, 6x cubed cancels, but this one, minus 13x squared, there's a minus sign in front. Minus minus becomes plus. So minus 13x squared plus 4x squared would be minus 9x squared. And we will drag plus 21x down. So plus 21x. And then we'll try and multiply 3x with something that gives us minus 9x squared. So 3 times minus 3 will give us minus 9. X times x will give us x squared. So we will get 3x times minus 3x will give us minus 9x squared. Let's multiply minus 2 with minus 3x, and that'll be plus 6x. And let's subtract the bottom from the top. So minus 9x squared cancels. 21x minus 6x becomes 15x. And then we can drag minus 10 down, minus 10. And then we'll have to think about the number that we multiply 3x with. So 3x times 5 will give us 15x. And then minus 2 times 5 will give us minus 10. And in this way, remainder becomes 0, and we have completely divided the cubic function with the factor. And we have obtained a quadratic in the process. So we can say, therefore, solving this equation means solving 3x minus 2 times the quadratic 2x squared minus 3x plus 5 equal to 0. So that means 3x minus 2 equals 0 and 2x squared minus 3x plus 5 equals 0. So we already have one root. 3x minus 2 equals 0 will give us x equals 2 over 3. That is one root. That is one intersection point. But to find more intersection points, we need to equate this quadratic to 0. Let's do that over here. So the quadratic is 2x squared minus 3x plus 5. So 2x squared minus 3x plus 5 equals 0. Now, we just need to show whether we have solutions for this equation or not. We don't need to solve this. So what we do is we can just use the discriminant to see how many solutions we can get. So the discriminant is b squared minus 4ac, where this is a, this is b, and this is c. So let's check. What is b squared minus 4ac equal to? So b squared minus 4ac is equal to, so b is minus 3 the whole squared minus 4 times a is equal to 2 times c is equal to 5. Okay, solve this. So minus 3 squared is 9 minus 4 times 2 is 8. 8 times 5 is 40. So we are getting a negative answer, negative 31. So if the discriminant is less than 0, that means there are no solutions. There are no roots. There are no intersection points. So the only intersection point we have is when x is equal to 2 over 3. Therefore, there is only one intersection point when x is equal to 2 over 3. And that's our final answer for question B. Okay, question 2. The quadratic equation 3x squared minus 5x plus 1 is equal to 0 has roots alpha and beta. Without solving the equation, form a quadratic equation with integer coefficients that has roots alpha over 2 beta and beta over 2 alpha. So let's break this down. First, it says that this equation has two roots, alpha and beta. And it says without solving this equation, we need to form another quadratic equation with integer coefficients, a, b, and c. This equation would have roots alpha over 2 beta and beta over 2 alpha. Okay, let's just use the rules that we've learned about sum of roots and the product of roots for the first equation. So if we use the sum of roots, alpha plus beta, this should be equal to minus b over a. So if we look at the equation, the b value here is minus 5. So it's going to be minus 5 divided by the a value. A value is 3. So we get 5 over 3 for sum of roots, alpha plus beta. Then we've also learned about the product of roots. the product of roots alpha times beta should be equal to c over a. So what is the c value here? C value is 1. So 1 divided by a value is 3. So 1 over 3. So we have the values of the sum of roots and the product of roots. And we'll leave these here. And then let's think about the other equation. So another quadratic equation. So if we think about another quadratic equation, it says the roots of this quadratic equation are alpha over 2 beta and beta over 2 alpha. So they also have this rule of sum of roots and product of roots. Let's try and find their sum of roots and product of roots. So sum of roots would be alpha over 2 beta plus beta over 2 alpha. And let's try and simplify this addition of fractions. So what we do is we try and find a common denominator. So we just need to multiply alpha to 2 beta and the numerator, so that it becomes alpha squared over 2 alpha beta plus, and with this fraction we need to multiply beta to 2 alpha and beta to the numerator, so that it becomes beta squared over 2 alpha beta. So finally this becomes alpha squared plus beta squared over 2 alpha beta. So we can see that we can substitute 1 over 3 in place of alpha beta. That's good. But what about the numerator? Can we replace 5 over 3 somehow over there? Not yet. We'll have to do more. So we can try this. So we know that a plus b the whole squared is equal to a squared plus 2ab plus b squared. And if we want to find a squared plus b squared, we need to send plus 2ab to the other side, so that it becomes a plus b the whole squared minus 2ab. So we'll be doing something similar here. So we have alpha squared plus beta squared, and we can convert this to this, which is alpha plus beta the whole squared minus 2 alpha beta. And we have the denominator 2 alpha beta. And now we can substitute these values. So let's do that. So alpha plus beta is 5 over 3, so this becomes 5 over 3 the whole squared minus 2 times alpha times beta is 1 over 3, and everything divided by 2 times alpha times beta, which is 1 over 3 again. Let's solve this using calculator. So this gives us 19 over 6. So the sum of roots for this new equation, new quadratic equation, is 19 over 6. This is the sum of roots. Now let's try product of roots. So alpha over 2 beta times beta over 2 alpha. Alpha over 2 beta times beta over 2 alpha. So this is the product of roots, and let's see what we get. So we get alpha beta divided by 2 times 2 is 4. 4 alpha beta. And we can cancel alpha beta top and bottom. So we end up getting 1 over 4. So this is the product of roots of the new quadratic equation. So the new quadratic equation would look like this. The new quadratic equation is ax squared plus bx plus c equal to 0. And let's divide everything by a, all the terms by a, so that this becomes x squared plus b over a x plus c over a equal to 0. So that this becomes x squared. I'm just going to manipulate this so that I would get minus b over a, which is equal to the sum of roots. So it becomes x squared minus b over a x plus c over a equal to 0. And we can see that we can substitute the new sum of roots here, which is equal to minus b over a, and we can substitute the product of roots here, which is equal to c over a. So therefore, the new equation is x squared minus the sum of roots 19 over 6 x plus the product of roots 1 over 4 equal to 0. And let's simplify this. So we can multiply all the terms by 12. so that we don't have any denominators. So 12x squared minus 12 divided by 6 is 2. 2 times 19 is 38x plus 12 divided by 4 would be 3. So 3 equals to 0. Can this be simplified any further? 38 is not divisible by 3. 3 is not divisible by 2. So we can't simplify any further. And this is the new quadratic equation that we wanted. 12x squared minus 38x plus 3 equals 0. So we have found this equation without solving the first quadratic equation. Okay, question 3. So we have a diagram. Figure 1 shows the sector AOB of a circle. So we have the sector AOB of a circle with center O. The center is there. The center of the sector is there. And the radius of this sector is 3r. That's the radius of the sector. And then a circle with radius r touches OA. So this circle touches OA and OB and the arc AB. So this circle completely fits into this sector. Okay, angle AOB is theta radians. That's the angle of this sector AOB, and that is equal to theta radians. And theta radians is an acute angle, which is between 0 and pi over 2 radians, which is less than 90 degrees. Find the exact value of theta. So we have to find the theta value with this given information. How can we do that? So we can see that this is a circle, and OA would be a tangent to the circle because it touches the circle at one point. And the angle between this line, this radius line, RCM, and the side OA is going to be 90 degrees. And we can form a triangle if we connect the center of the circle to the center of the sector. Okay, let's try this. And then we can see that this angle here would be equal to pi over theta over 2. This would be theta over 2. And what else do we know? So for this angle theta over 2, the opposite side is r centimeters. The adjacent side, we don't know whether the circle touches line OA right at the middle or not. We have no idea about that. So we won't be able to find this length. What about this length here? We know the radius of the sector is 3r cm. So if we extend this line up until there, we know that this is the radius of the circle. So this is going to be r centimeters. And the distance from here to there, the hypotenuse of this triangle, has to be 2r. So that this entire blue line from O to this point is equal to 3r, which is the radius of the sector. So that's how we know the hypotenuse of this triangle that we formed is equal to 2r. So we know the opposite side, which is rcm, and the hypotenuse, that is 2rcm. And we can use trigonometry to solve the theta value. So we can say sine theta over 2. So question A, sine theta over 2 is equal to opposite side r divided by hypotenuse 2r. R divided by 2r. And this becomes sine theta over 2 equals half, because r cancels. And we know that sine 30 degrees is equal to half. Or we can just use our calculator. We can just do theta over 2 is equal to sine inverse 1 over 2. And that will give us 30 degrees in degrees. But let's solve this in radians. So in radians, 30 degrees is equal to 30 is 1/6 of 180. So that's going to be pi over 6. And we're not going to use the unit circle, and find the other angles, because we already know that theta is an acute angle. We can just go ahead with the calculator answer. So theta would be 2 times pi over 6, which is pi over 3. So theta is equal to pi over 3. That's the answer for A. Now, question B. The area of the region shown shaded in figure 1 is 8 pi cm squared. Find the value of r. So we can see the shaded area can be found if we subtract the circle area from the sector area. Now we also know the value of theta. So let's just use the formula, the area formula. So we can say, question B, area of shaded region is equal to the value they have given us, 8 pi cm squared. So area of the shaded region is 8 pi cm squared. How do we calculate the area of the shaded region? We will subtract the area of the circle from sector area. How do we calculate the sector area? The sector area is half r squared theta. That's the formula. We'll substitute the values later. And minus the circle area, which is pi r squared. And that is equal to 8 pi. Now let's substitute the real value. So half, the radius of the sector is 3r squared times the theta value, the angle of the sector is pi over 3, and then minus the circle area is pi times, the radius is just r, so it's just pi r squared is equal to 8 pi. We formed the equation. From here we just need to find the value of r. Let's simplify this. So half times 3 squared is 9, r squared is r squared, times pi over 3 minus pi r squared equals 8 pi. So we have numbers 9 divided by 3 will be 3, and then we have half. So this becomes 3 over 2 pi r squared minus pi r squared is equal to 8 pi. 3 over 2 is just 1.5. So 1.5 minus 1 is 0.5. So we will get half pi r squared is equal to 8 pi. And we've got pi on both sides of the equation. We can just cancel them. So half r squared is equal to 8. R squared is equal to 8 times 2 is 16. R is equal to plus or minus square root of 16. We will ignore the minus because radius cannot be negative. So it's just square root of 16, which is equal to 4. The radius of the circle, R value, is 4 centimeters. And that's it. The question says, find the value of R. R is equal to 4 cm. That is question B. Okay, question number 4. So we have a graph. Figure 2 shows part of the curve with the equation y equals x squared over 3 minus 1 over 2x for the region minus 4 less than x less than 0. So between minus 4 and 0, we can see the curve. By drawing a suitable straight line on the grid, obtain estimates to 1 decimal place of the roots of the equation, which is a cubic equation, in this interval for x values between minus 4 and 0. So we have to use the graph to find the roots of this cubic equation. So what do we have to do is we can think about a straight line that intersects with this curve. So the intersection points of the straight line and the curve, the x values of the intersection points, will basically be the solutions or the roots of this equation. So I'll write down this equation. The equation is 4x cubed plus 3x squared minus 36x minus 6 equals 0. And what do I need to do to this equation? On one side of the equation, I need to have an expression that looks like this, exactly like this. And on the other side of the equation, I need a linear equation, a straight line equation. So that'll be a case where we would be finding the intersection points of this linear equation and the curve equation that we have. So we need to do that. So let's think about how we can turn this cubic into this x squared over 3 minus 1 over 2x. So let's do it step by step. We can start by dividing all the terms by x so that the largest term is x squared. So if we divide all the terms by x, this becomes 4x squared plus 3x minus 36 minus 6 over x equals 0. So now what I'm going to do is I can see that in the curve equation, we have an x squared term, and we have a term where there's x in the denominator, only these two terms. So I will keep 4x squared and minus 6 over x on the left side of the equation, and I'll move every other term to the right side of the equation, so that becomes minus 3x plus 36. Now, we need to make this look like this. So first we'll have to divide all the terms by 4. Actually, should we divide by 12? I think we should divide by 12 so that we would have over 3 remaining. So, okay, that's just my instinct, but let's go with that. We should divide all the terms by 12. So if we divide 4 by 12, we will get 1 over 3. So this becomes x squared over 3. Then we will divide 6 over x by 12, so that it becomes 1 over 2x. Now it looks exactly like this, which is great. But we have to continue dividing all the terms by 12 on the right-hand side as well. So minus 3x divided by 12 would be minus 3 over 12 is 1 over 4, 1 over 4x. And then 36 divided by 12 is 3. So this is what we get. Now we have this curve equation drawn on the graph, and we just need to draw this linear equation, the straight line equation on the graph, and we have to find the intersection points. So the linear equation is the straight line equation is y equals minus 1 over 4x plus 3, which means the y-intercept is 3 and the gradient is negative 1 over 4. So let's draw this. So y-intercept is 3, so let's put a cross on the y-axis where the value is equal to 3. And then if the gradient is negative 1 over 4, we can say rise divided by run is equal to negative 1 over 4. So for every 4 units we run, we have to fall by 1 unit. So, but we cannot run forward, so we have to go backwards. So if we run backwards by 4 units, we will rise by 1 unit because the gradient is negative 1 over 4. So we will run backwards from here. So 4 units will be here, and then we'll have to rise by 1. So the next cross would be here. That's one way of thinking about it. Like if we start from here, what are we doing? We are running 4 units forwards, and then we are falling 1 unit down so that we reach the second point. Anyway, we have 2 plots for the linear equation, and we can just connect them to get a straight line. Where are the intersection points? So the intersection points are here and there. So what are these values? So the first intersection point has a value of negative 3.33, negative 3.35. I would say it's closer to negative 3.3 because the question said obtain estimates to 1 decimal place. So I'll just leave my first intersection point to be negative 3.3. The second intersection point is around negative 0.1. Looks closer to negative 0.2, so I would say this is negative 0.2. So from the graph, the intersection points, or you can say the roots of the equation, are x equals negative 3.3 and negative 0.2. These are our answers. Negative 3.3 and negative 0.2. This is question 4. Question number 5. So we have this equation y equals e to the power 2x times, in brackets, x squared minus 5x. And we need to show that 2e to the power 2x is equal to d squared y over dx squared minus 4 times dy over dx plus 4 times y. So we have y dy over dx and d squared y over dx squared. So we have an expression for y. Let's find the expressions for dy over dx and d squared y over dx squared. So since we have an expression for y, dy over dx will be equal to, so what do? We have e to the power 2x multiplied to this bracket. So we can see that they're multiplied, so we have to use a product rule. So what is a product rule? Dy over dx is equal to u times dv over dx plus v times du over dx. So for us, u is e to the power 2x, v is x squared minus 5x. So let's apply that. So dy by dx would be e to the power 2x, which is u, times dv over dx. So we need to differentiate the bracket. If we differentiate the bracket, we will get 2x minus 5. So that is u dv over dx. Now, plus v. V is x squared minus 5x times du over dx. So if we differentiate e to the power 2x, we will get 2 times e to the power 2x. So 2 e to the power 2x. If I rearrange the equation, dy over dx is equal to e to the power 2x times 2x minus 5 plus, we can move 2 in front. So 2, we can also move e to the power 2x in front. 2 times e to the power 2x times x squared minus 5x. Okay, let's leave it this way for now, and let's see what happens when we differentiate this again for d squared y over dx squared. So d squared y over dx squared can be found by differentiating dy over dx with respect to x. So we have to differentiate this first. So again, we'll use the product rule, u dv by dx plus v du by dx. So u is just e to the power 2x times dv by dx is going to be just 2 plus v du by dx. So v is 2x minus 5 times du by dx would be 2 e to the power 2x. That's the first part of dy by dx that is differentiated already. Then plus, for the second part, we have to use the product rule again. So u would be 2 e to the power 2x. So it's going to be u, which is 2 e to the power 2x times, let me put these in brackets. So that's the first part, that's the second part. So u is done. Dv over dx would be differentiating this bracket, which is 2x minus 5. Then plus v du over dx. So v is x squared minus 5x times du over dx is differentiating this, which is 2 times 2, 4 e to the power 2x. So let's rearrange this. The first bracket is 2 e to the power 2x plus 2 e to the power 2x times 2x minus 5. And then the second bracket is 2 e to the power 2x times 2x minus 5 plus 4 e to the power 2x. Let me fix this. 4 e to the power 2x times x squared minus 5x. So we have an expression for d squared y by dx squared. So can we use this expression and replace some of the terms by dy by dx and some by y? Let's have a look. We have to analyze very carefully. If you look at all of this, that is twice of dy over dx. So 2 times dy over dx will give you this. So we can say this could be turned into plus 2 dy over dx. And we can see that we already have a term 2 times e to the power 2x, which is there in the equation. We have figured out dy over dx. We already have d squared y over dx squared here. We need to get 4y somehow. What should this be replaced with? So 2 times e to the power 2x times 2x minus 5. And if you think carefully, it can be obtained if we subtract y from dy over dx. Not only y, actually 2 times y. If 2y is subtracted from dy over dx, this time is gone, and we'll have e to the power 2x times 2x minus 5. So this would be dy over dx minus, from this, if we subtract 2y. If we subtract 2y, this will be gone, because 2y would be 2 e to the power 2x times x squared minus 5x. So it exactly matches this, and this will be gone. Dy by dx minus 2y will just give us e to the power 2x times 2x minus 5. Let's substitute those values here. So all of this is the same as 2 times dy over dx. Let me remove this and let's rewrite this. So this becomes d squared y over dx squared equals 2e to the power 2x plus, we have this 2 here, 2 times dy by dx minus 2y, which is this. We've replaced it, and plus this 2 times dy over dx. Let's simplify this further. So 2e to the power 2x plus 2 dy over dx minus 4y plus 2 times dy over dx, and all of this is equal to d squared y over dx squared. And then let's simplify this further. We can see 2 dy over dx there, 2 dy over dx there, and this becomes 2e to the power 2x plus 4 dy over dx minus 4y, and that is equal to d squared y over dx squared. Now let's make 2e to the power 2x the subject of the equation as asked. So 2e to the power 2x is equal to, we'll move all of these terms to the other side. So we start with d squared y over dx squared. So this on the other side would be minus 4 dy over dx, and this on the other side would be plus 4y. And that is exactly what is asked. So this can be very difficult. In case you don't want to do this method, you could also just simplify the right-hand side by replacing the expressions that we found. So the expressions for d squared y over dx squared can be substituted there. The expression for dy by dx can be substituted there. The expression for y can be substituted there. And that would be the right-hand side. You simplify it, and after you simplify the right-hand side, it should be equal to left-hand side. That's another way to solve this question. It can be longer, but it won't be very difficult. This method can be difficult, but it is faster and shorter. So that's the end of question 5. Question 6. So we have a graph. Let's read the question. Figure 3 shows part of the curve C with equation y equals 1 over 4x. So we can see this is curve C. It's a reciprocal curve, and it is only shown where x values are positive. That is curve C. And then part of the curve S with equation y equals 2x squared. So that's a parabola, curve S. We can see that's a parabola. And again, this is only shown where x values are positive. The curve C and the curve S, they intersect at the point A. Yes, they intersect at this point A. Question A, find the coordinates of point A. So to find the coordinates of point A, we just have to equate the two curve equations. So question A, we can say for point A, 1 over 4x is equal to 2x squared. So curve C equated to curve S. So we can move 4x to the other side. So 1 is equal to 4 times 2 is 8, x cubed. We can move 8 to the left-hand side. So 1 over 8 is equal to x cubed. And then we can see that x is equal to cube root of 1 over 8. And when we cube root 1, we just get 1. When we cube root 8, we get 2. So x equals half is where point A lies. We also need to find the y coordinate. So we can use the curve S equation. That's easier. So when x equals half, using curve S, y is equal to 2 times half squared, which is 2 times 1 over 4, which is equal to 2 over 4, and that is half as well. So y is also equal to half. That means point A is equal to half comma half. So this point is half comma half. So that is question A. Now question B. Question B, the finite region R shown shaded in figure 3. So yes, we can see the shaded region R is bounded by the curve C, the curve S. So it's bounded by the curve C, the curve S, and the straight line y equals 4, which is this horizontal line, y equals 4. So this region is rotated through 360 degrees about the y-axis. So question B says, find, using algebraic integration, the exact volume of the solid form. So we need to use the formula for volume of revolution. So volume is equal to pi times integral of y squared with respect to x. And this is rotated through the x-axis. If it's rotated about the y-axis, things change. So this is about x-axis. If it is rotated about the y-axis, volume formula would be pi times integral of x squared with respect to y, about y-axis. Okay, let's see how we can solve this. So if we rotate it about the y-axis, the limits would be y equals half to y equals 4, and the region would be between S and C. Let's rewrite the curve equations, making x the subject. So for curve C, y is equal to 1 over 4x. 1 over 4x. If we make x the subject, this becomes x equals 1 over 4y. Okay, this is easy. And then for curve S, y equals 2x squared. Y equals 2x squared. If we make x the subject, it becomes x squared is equal to y over 2. So x squared is equal to y over 2. And we could find what x is equal to, but we don't need to, because when we use this formula, the volume formula, we'll be using x squared, and we have x squared. We don't need to find what would x be equal to. So we have an expression for the curve S. We have an expression for the curve C. So to find the volume of revolution rotated through 360 degrees about the y-axis for this region R, what do we need to do is we can think about it like this. We can find the volume of revolution for the region under the curve S between the limits 4 and half. So this red area will be rotated through 360 degrees about the y-axis, and there will be a volume. From that volume, this new volume would be subtracted. So this new volume would be formed rotating this green area through 360 degrees about the y-axis. And this green area is the area formed between the curve C and the y-axis. So this is how the equation would look like. Volume of revolution is equal to volume due to curve S minus volume due to curve C. So volume S minus volume C. So let's write down the formula for volume of revolution for curve S. That will be pi times integral with limits going from 0.5 to 4 of x squared with respect to y. So for curve S, x squared is equal to y over 2. So it's going to be y over 2 with respect to y. That is volume S. And then volume C would be pi times integral. Limits go from 0.5 to 4 again. X squared dy. The value of x for curve C is 1 over 4y. So the value of x squared would be 1 over 4y the whole squared, which is 16y squared with respect to y. And then we just have to integrate these. So this becomes pi times, let's integrate. We have a power of 1 right now, y to the power 1. We need to add 1 more, so it becomes y squared, and then we'll have to divide by 2. So it becomes y squared over 4. And we apply the limits 4 and 0.5. So that's the integral for volume S. Subtract pi times the integral for volume C is going to be, so we need to change the form. We have 1 over 16 y squared. We could change this to y to the power minus 2 over 16 so that we can integrate this easily. So y to the power minus 2, we need to add 1 to this so that it becomes y to the power minus 1. And we divide by minus 1 so that there's a negative sign in front. It becomes minus y to the power minus 1 over 16, which is the same as 1 over 16y. And then we close the bracket and we apply the limits 4 and 0.5. And then we will apply the limits now. So pi times. The upper limit value would be 4 squared over 4 minus the lower limit value would be 0.5 squared over 4 minus pi times the upper limit value would be minus 1 over 16 times 4, which is 64, minus 1 over 16 times 0.5, which is 8. Let's use our calculator and solve this. So the upper limit value, 4 squared over 4 minus 0.5 squared over 4 gives us 63 over 16. So this is 63 over 16 pi minus the lower limit value, minus 1 over 64 plus 1 over 8 is 7 over 64. So we have minus 7 over 64 pi. And if we subtract these, 63 over 16 minus 7 over 64, we get 245 over 64 pi. And that should be the answer for question B. The volume of revolution of the shaded region when rotated through 360 degrees about the y-axis. That is 245 over 64 pi. Okay, question 7a. Expand 1 plus 2x squared, the whole to the power minus 3 over 4 in ascending powers of x, up to and including the term in x to the power 6. Express each coefficient as an exact fraction in its lowest terms. So we need to use the binomial expansion formulae. So question A, we need to expand 1 plus 2x squared to the power minus 3 over 4. So we'll be having many terms when we expand this bracket. Let's just check the formula on how to expand this. So we can check the second page of this paper, and we have the formula here under binomial series. So if you have 1 plus x to the power n, it is equal to, the 0th term is going to be 1 plus the first term is going to be n times x, where n is the power, x is the second term in the bracket. The second term is going to be n times n minus 1 divided by 2 factorial times x to the power 2. So the third term would be n times n minus 1 times n minus 2. Because it is a third term, it'll be divided by 3 factorial and times x to the power 3, because it would be the third term. And it goes on like this. So let's go back and check and apply this formula. So what do we need to do? We need to expand this up to and including the term in x to the power 6. So the 0th term is just going to be 1 plus n times x. So n is minus 3 over 4. X here, the second term within the bracket is 2x squared. So minus 3 over 4 times 2x squared. This is the first term. So let me rewrite the formula here. If we have 1 plus x to the power n, the 0th term is going to be 1, the first term is going to be n times x, the second term is going to be n times n minus 1 divided by 2 factorial times x squared, and this continues. So we have written it till the first term. Next, the second term would be n times n minus 1, so minus 3 over 4 times minus 3 over 4 minus 1. Okay, let me use a calculator. So minus 3 over 4 minus 1 gives me minus 7 over 4. Minus 7 over 4. So n times n minus 1 done. Since this is the second term, it's going to be divided by 2 factorial times, we'll be multiplying this with 2x squared to the power 2. So if you look at this term, if we apply the power 2, it becomes x to the power 4. So we still need to write more terms to get to x to the power 6. So let's do that. The next term would be the third term, so plus n times, so our n value is minus 3 over 4, n times n minus 1. So So the third term would be n times n minus 1 times n minus 2 divided by 3 factorial times x to the power 3. So n has been written. N minus 1 would be negative 7 over 4. And n minus 2, let's check. So minus 3 over 4 minus 2 gives me minus 11 over 4. So n times n minus 1 times n minus 2 divided by 3 factorial this time times x to the power 3. So our second term within the bracket is 2x squared to the power 3. And if we expand this bracket, yes, this time we get x to the power 6. So we can stop here. So this is the expansion, but we need to simplify this. We need to express each coefficient as an exact fraction in its lowest terms. Okay, let's rewrite this. So this is going to be equal to 1 plus, let's look at the first term, not the zeroth term. Zeroth term is 1. So the first term, if we multiply minus 3 over 4 with 2, let's just use the calculator. So minus 3 over 4 times 2 gives me minus 3 over 2. So the sign is going to be negative 3 over 2 x squared. Okay, plus. Now the second term. So let's use the calculator to solve this. Negative 3 over 4 times negative 7 over 4 divided by 2 factorial times this thing. If we apply the power 2, it'll be 2 squared, so times 2 squared. So that gives me 21 over 8, and x squared to the power 2 would be x to the power 4. So that's the second term, and then the third term. So I'll be calculating all of this on my calculator, including 2 to the power 3 as well. So we have minus 3 over 4 times minus 7 over 4 times minus 11 over 4 divided by 3 factorial times 2 to the power 3. And that gives me negative 77 over 16. And x to the power 2 to the power 3 would be x to the power 6. And that's it. We have expressed all the coefficients as an exact fraction in their lowest terms. That is the answer for A. Now let's look at question B. Question B, we are given this function f of x is equal to 2 plus kx divided by 1 plus 2x squared, the entire thing to the power 3 over 4. And it looks similar to this. And if we just move this denominator to the top, it'll look exactly like the one we expanded earlier. Okay, we could do that. And then they also say k is not equal to 0. So we have an unknown here, k, and it's not equal to 0. Question B says, obtain a series expansion for f of x, the entire function, in ascending powers of x up to and including the term in x to the power 5. We need to move this denominator to the top so that it looks like what we expanded in A, and we could multiply 2 plus kx with the expansion terms up until the point we get x to the power 5. They also say that give each coefficient in terms of k where appropriate. So question B, f of x is equal to 2 plus kx, and then let's just move the denominator to the top so that it becomes 1 plus 2x squared, the entire thing to the power minus 3 over 4, where k is not equal to 0. So since we have the expansion, we can substitute the bracket with the expansion. So this is just going to be 2 plus kx times the expansion, which is 1 minus 3 over 2 x squared plus 21 over 8 x to the power 4. And I would like to stop here because we only need to show the terms up until x to the power 5. We don't need any bigger terms than x to the power 5. And there's no need to include this term, negative 77 over 16 times x to the power 6. We are ignoring that term. Now, when we think about it, if we multiply 2 to all of these terms, we will get terms up to the power x to the power 4. But if we multiply the kx term with all of these terms, since kx term has x there, if that multiplies with 21 over 8 x to the power 4, we will get a term in terms of x to the power 5. So That's enough. We just need to multiply these two brackets. So let's do that. Let's multiply with 2 first. So 2 times 1 is 2. 2 times minus 3 over 2 is just going to be minus 3 x squared. Then 2 times 21 over 8 will be 21 over 4 x to the power of 4. So we're done multiplying 2 with all the terms in the second bracket. Now let's multiply kx with the terms in the second bracket. So kx times 1 is going to be kx. Kx times minus 3 over 2 x squared would be minus 3 over 2 k x to the power of 3. Then kx times plus 21 over 8 x to the power of 4 would be plus 21 over 8 k x to the power of 5, and that's it. Let's rearrange this in ascending order. Give each coefficient in terms of k where appropriate. Okay, so let's start with the constant term 2. Then we have a term with x to the power of 1, which is plus kx. Then we have a term with x to the power of 2 minus 3x squared. Then comes minus 3 over 2 kx cubed. Then comes plus 21 over 4 x to the power of 4. And the last term is plus 21 over 8 k x to the power 5. And that's it. That is the answer for question B. How many terms do we have? 1, 2, 3, 4, 5, 6. We had 1, 2, 3, 4, 5, 6. So no mistakes made. That's the final answer for B. Let's look at C. So question C, what does it say? It says the coefficient of the term in x to the power 5 is 14 times the coefficient of the term in x squared. Find the value of k. So coefficient of the term in x to the power 5, what is it? If we look at x to the power 5 term, the coefficient is 21 over 8k, and this coefficient is 14 times the coefficient of the term in x squared. So the coefficient of the term in x squared is minus 3. So it's 14 times minus 3. From here, we can find the value of k. So we can move 21 over 8 to the other side. So k is equal to 14 times minus 3 gives me negative 42. So negative 42 times 8 over 21. So, okay, 21 1s are 21, 21 2s are 42. 8 times 2 is 16, and there's a negative sign. It's going to be negative 16. K is equal to negative 16. That's what we get for k. And that's everything for question 7. Okay, question 8. So we have a 3D diagram. Figure 4 shows a solid right triangular prism A, B, C, D, E, F. So it's a right triangular prism. So we can see a right triangle and it's a prism. The cross section of the prism is an isosceles triangle. So it's not only a right triangle, it is also an isosceles triangle. That means DE and CE are equal. We're told that angle DEC is equal to angle AFB. They're 90 degrees. So side AB is equal to side DC, and it is called XCM. Then the third point, AD is equal to BC is equal to FE. And then the last point, side AF is equal to BF is equal to DE and CE. So AF, BF, DE, and CE, they're all equal because the triangle is isosceles. Okay, the triangular faces of the prism are vertical. So this face is vertical. And the edges AD, BC, and FE. So AD, BC, and FE are horizontally oriented. Okay, now the volume of the prism is 3.6 cm cubed. The total external surface area of the prism is S centimeters squared. Question A, show that S satisfies the equation that is given here. And when we look at the equation for S, it is written in terms of X. There's no Y mentioned here, it's only in terms of X. In the diagram, we have two unknowns, X and Y. Okay, so we have to show that S is equal to this. But before we deal with the surface area, let's try and find an expression for Y in terms of X. So we can do that if we use the volume information, 3.6 cm cubed. So we can say, question A, volume can be calculated by multiplying the cross-sectional area with the length of the prism. What is the length of the prism here? The length of the prism is y. So area of the cross-section times y will give us the volume. And we know what the volume is. Volume is 3.6. And what is the area formula? Let's have a look. So if this triangle, the cross-section, which is a right triangle, the length DE and length CE are perpendicular. So DE can be the height, EC could be the base. So area of triangle would be half times base times height. That means it is just half times CE times DE. But we don't know what it is in terms of x. So first of all, we have to find the expression for CE, DE in terms of x. We know that AB is equal to x, DC is also equal to x. Let's redraw this triangle, DCE. So we have the triangle DCE. This is 90 degrees, and this is x. We know the hypotenuse. If we know the hypotenuse, we'd be able to find the adjacent sides as well. So let's just call the adjacent sides A for now. If this is A, this is also A. So what's the relationship between x and A? If we use Pythagoras, x squared is equal to a squared plus a squared. That means 2a squared is equal to x squared. That means a squared is equal to half x squared. And then we have an expression for a now. So a would be square root of all of that. So we won't be using plus or minus sign because we're dealing with length. Length is always positive. So it's going to be 1 over root 2 x. That is the value of a. If we simplify this, we can multiply both the top and bottom by root 2 so that this becomes root 2 over 2. Root 2 over 2x. Okay, so if a is equal to root 2 over 2x, we can say the area is half times base times height times y. And the volume equation becomes 3.6 equals half times the base is equal to a. Let's say this is the base and this is the height. They're both the same. They are root 2 over 2x times root 2 over 2x, half times base times height, and times y. So 3.6 is equal to, let's multiply the denominators, 2 times 2 times 2, that is 1 over 8, so 1 over 8, times root 2 times root 2 is just 2, times we have x, and y. So that is x squared y. And then 1 over 8 times 2 would be 1 over 4 x squared y. On the other side, we have 3.6. Let's make y the subject of the equation. Y is equal to 4 times 3.6 divided by x squared. So what is 4 times 3.6? That gives us 14.4. So y is equal to 14.4 divided by x squared. So we have an expression for y in terms of x. Okay, now we can find the surface area of this prism. So let's write down the formula for the surface area. So how do we think about the surface area? We can think about it this way. Let me annotate the values of the sides here. So the side AD, which is equal to y, can now be written as 14.4 over x squared. So this is 14.4 over x squared. DC is XEM. The side DE, we found it to be root 2 over 2x. And this is CE is also root 2 over 2x. Let's think about the surface area. So let's deal with this surface first. This is a rectangle. To find this area, we have to multiply x with 14.4 over x squared. Okay, so that is the first area, the top face of this 3D diagram. Then these faces here, this is also a rectangle. It's the same as the face on this side. So we have two such faces. The area of one of these faces is this length, which is root 2 over 2x, times this length, which is 14.4 over x squared. So let's write that down. We have two such faces. So 2 times root 2 over 2x times 14.4 over x squared. So we have accounted for the faces on top and the faces, the rectangular faces, by the way. All three rectangular faces have been covered. And we just need to take into account the front face and the back face, which are triangular basis. So to find the area of this one, it's just half times base times height. So it's going to be half times root 2 over 2 x squared. So 2 times half times root 2 over 2 x squared. Let's simplify this. So this first bracket becomes 14.4 divided by x plus the second bracket 2, and this 2 cancels. So we have 14.4 root 2. This x and this x squared cancel, so we have denominator x plus this 2 and this 2 cancel. So root 2 over 2 the whole squared would be 2 over 4 x squared. So what do we have now? What do we need to show? X squared over 2, 72 over 5. So we can factorize 14.4 over x. So let's factorize 14.4 over x. What remains is 1 plus root 2 from the first two terms. And then the last term is 2 over 4 is just going to be half x squared. So to make it look like this, let's write half x squared as x squared over 2 plus. Now this one, 14.4, let's turn the decimal into a fraction with integers only. So 14.4 can be written as 72 over 5. So that becomes 72 over 5, and we have x in the denominator. So 72 times, they want root 2 plus 1. So yes, we have 1 plus root 2, which is the same as root 2 plus 1 divided by 5x. And that's the expression of the surface area of the 3D shape. That is question A. Now let's look at question B. Given that x can vary, use calculus to find to 3 significant figures the value of x for which s is a minimum. Justify that this value of x gives a minimum value of s. So if x can vary, s can also vary. We can find ds by dx, and we can find the minimum value of s. Or we can find the value of x for which it gives a minimum value of s. So we have this. Now we need to differentiate this with respect to x. So let's rewrite this in a way that it's easy to differentiate. So this is half x squared plus 72 over 5, and these numbers root 2 plus 1 times x to the power minus 1. So here we have started question B. If we differentiate this, this become ds over dx. Let's differentiate the first term. So 2 can be sent in front. So 2 over 2 is just 1. And then the power, we have to subtract 1 from this, so the power remains 1. So the coefficient is 1, the power is 1, it's just x. When we differentiate the second term, if we look at the x value, the power is minus 1. So we have to send this power in front, so that becomes minus. We leave the coefficient as it is, and then we have to subtract 1 from the power. So the power becomes x to the power minus 2. And that is ds by dx. We could also rewrite this into x minus 72 bracket root 2 plus 1 divided by 5x squared. And to find the minimum value of s and its corresponding x value, we need to say that ds by dx is equal to 0, because we want to find the turning point. The maximum or the minimum point is a turning point. It happens when the gradient becomes 0. So this is for minimum point. We have to make ds by dx become 0. So if that becomes 0, the expression x minus 72 times root 2 plus 1 over 5x squared becomes 0. So x is equal to, we can move this term to the other side, 72 times root 2 plus 1 over 5x squared. Let's move x squared to this side so that it is x cubed. 72 times root 2 plus 1 over 5. Since we need to find this in decimals, we just need to cube root the value. We need to find the value to 3 significant figures though. So what is the value of x? X will be the cube root of all of this. 72 root 2 plus 1 over 5. This gives us 3.2637. 3.2637. Okay, so we can round this to 3 significant figures. That means this is the first significant, second significant, third significant. We need to show up until this value. And the next value is less than 5, so we don't need to round this one up. So it's just going to be 3.26. That's the value of x where the minimum value of surface area happens. But we need to prove that it is going to be a minimum value of s. So to do that, to check whether it's a minimum value or maximum value, we have to differentiate s again. So we need to find d squared s over dx squared. So we already have an expression for ds over dx. We have to differentiate this again. So if we differentiate x, we just get 1. So 1. And then next we have to differentiate this one. So the power of x is -2. So we will move -2 in front. When we do that, it multiplies with -72/5. So -2 times -72/5 gives us 144/5 positive. So the coefficient becomes 144/5, and in brackets we had √2 plus 1. What happens to x? We subtract 1 from the power again, so that this becomes x to the power -3. X to the power -3. So if we rewrite this without the negative power, it becomes this divided by 5x cubed. To check whether the value of s would be maximum or minimum, when x is equal to 3.26, we need to substitute x equals 3.26 into the d squared s over dx squared. So when x is equal to 3.26, d squared x over dx squared is equal to 1 plus 144 times √2 plus 1 divided by 5 times 3.26 cubed. And let's see what we get. We'll get a positive value for sure. Yes, we do get a positive value. We get 3.006 and so on, which is greater than 0. So when d squared s over dx squared is positive, that means the value of s would be a minimum value. So therefore, it'll be a minimum value of s. Then finally, we can say the minimum value of s occurs when x is equal to 3.26, and that's our answer. Okay, what do we need to do next? So this was question B. Question C. So question C is hence find to 2 significant figures the minimum value of s. So we know the x value when s is minimum. So let's replace this x value in the s equation. So we have the s equation here. We just need to replace 3.26 in place of x. So we can say s minimum is equal to, let's have a look at the s equation. This one here. So x squared over 2. So that will be 3.6 squared over 2. Sorry, 3.26 squared over 2 plus 72 times √2 plus 1 divided by 5x. So 72 times √2 plus 1 divided by 5 times 3.26. Let's see what we get. 15.97. And we need to find this to 2 significant figures. So only 1 and 5. And the next one is 9, which is larger than 5. So we need to round the second significant figure up. So it becomes 16. And because this is a surface area, the lengths are given in centimeters, so this is going to be centimeters squared. 16 centimeters squared. That's a minimum value of the surface area of this prism. And that's the end of question 8. Question 9. So we have another 3D shape. Figure 5 shows a right triangular prism, again, ABCDEF, where ABCD is a rectangle. So we can see ABCD is the bottom face, which is a rectangle. Okay. AF is equal to DE. So AF and DE are equal. All right. BF is equal to CE. So BF and CE, these two lines are equal. And then AD is equal to FE, and that is equal to BC. So AD, FE, and BC, they're all equal. Okay, next AB and DC are equal to 24. So AB, this length, and DC, they're both equal and they're equal to 24 centimeters. And then ABF is equal to angle DCE, which are 45 degrees. So angle ABF and angle DCE are 45 degrees. Next is the 60-degree angle BAF and angle CDE. BAF and CDE. Okay. What does the question say? Using a formula from page 2, show that sine AFB is equal to this value. Sine AFB, so AFB is here. Since we know the other two angles in the triangle, we can calculate the angle AFB. So let's do that first and see what happens when we have sine in front. So angle AFB would be equal to 180 degrees minus, we have to subtract 60 degrees and 45 degrees. So minus 60 degrees and 45 degrees. 60 and 45, when we add them, we get 105. If we subtract 105 from 180, we get 75. Angle AFB is equal to 75 degrees. That means sine AFB is equal to sine 75 degrees. And we have to find the value of sine 75 using a formula from page 2. And it'll produce numerical value with sets. The only way we can do that is by using special angles or using the trigonometric formulae from page 2. Let's have a look at page 2. So if we look at page 2 under trigonometry, we have sine. So we can use this formula. Sine A plus B is equal to sine A cos B plus cos A sine B. So right now we have sine 75, and we need to split 75 into two angles which are special angles, either 30 degrees, 45 degrees, or 60 degrees. So we can split 75 degrees into 30 degrees and 45 degrees. So let's apply the formulae. Sine A plus B is equal to sine A cos B plus cos A sine B. So this will be sine 30 cos 45 plus cos 30 sine 45 after applying the formula. So what is that equal to? We should remember the values of the special angles. So sine 30 is equal to half times cos 45 is equal to root 2 over 2 plus cos 30 is equal to root 3 over 2 times sine 45 is also root 2 over 2. So let's simplify these. Let's check what they want. They want this, root 2 plus root 6 divided by 4. So half times this root 2 over 2 would be root 2 over 4. And the second term would be root 3 times root 2 is root 6. If we apply the third rules, divided by 2 times 2 is 4. That means we have found the value that they want, root 2 plus root 6 divided by 4. So that is root 2 plus root 6, everything divided by 4. That is question A. Now next, without using a calculator, show that BF is equal to this. So what is BF? Let's have a look. So BF is this length here on this triangular face. AFB is 75 degrees. So we know all the angles here. We know one side, AB. We want to find the other side, FB or BF. We can use the sine rule. So the angle opposite to BF is 60. The angle opposite to 24 is 75. Let's set up the sine rule formula. So BF over sine 60 is equal to 24 over sine 75. So question B, BF over sine, the angle was 60, is equal to 24 over sine 75. So BF would be equal to 24 over sine 75 times sine 60. So let's use a calculator. Should we use a calculator or should we do it without using a calculator? So without using a calculator, we already know what sine 75 is. That is root 2 plus root 6 divided by 4. So this will be 24 over root 2 plus root 6 divided by 4. So we can move 4 to the top. The reason is 24 divided by sine 75 can be written this way. And then we have times sine 60 that comes after. And then if we change the division sign to multiply sign, we have to take the reciprocal of the following term. So this becomes 24 times the reciprocal of sine 75, which is 4 over root 2 plus root 6, and then times sine 60. What is sine 60? This is a special angle. Sine 60 is the same as cos 30, which is root 3 over 2. We have to simplify this. So what can we cancel? We can cancel 2, and 2 2s are 4. So 24 times 2 is 48. So 48 root 3 in the numerator. The denominator is root 2 plus root 6. Are we supposed to simplify the denominator? Yes, we do need to, because we don't have a denominator here. So we have to rationalize this denominator. Root 2 plus root 6. How do we get rid of this? We can multiply with root 2 minus root 6, top and bottom. So multiply root 2 minus root 6. Let's see what happens. So this gives us 48 root 6. And then 48 root 3 times minus root 6 would be minus 48. 6 times 3 is 18, root 18. Divided by root 2 times root 2 is just 2. We can ignore the middle terms because the middle terms will cancel. Root 6 times root 6 is 6, so 2 minus 6. Let's check if we can simplify this further. So 48 root 6 minus 48. Root 18 can be split into root 9 times root 2, and then 2 minus 6 is minus 4, and then both of these are divisible by 4. So the first term is going to be 48 divided by 4 is 12, so we'll have minus 12 root 6, and then that is going to be plus 12. Root 9 is 3 and times root 2. So minus 12 root 6 plus 36 root 2. What does the question want? It wants the 12 to be factored out. So if we factor out 12, it'll be minus root 6 plus 3 root 2. And they want us to write the positive term first. So 3 root 2 minus root 6. Let's check now. Okay, it matches now. So the answer is 12 times, within the brackets, 3 root 2 minus root 6 centimeters. Yes. This is question B. Next, question C. The angle between the plane AEB and the plane ABCD is 65 degrees. So angle between the plane AEB. Let me draw lines from point A to point E, and then point B to point E. So this is this triangular plane AEB, and we need to find the angle between that triangular plane AEB and the floor, the plane ABCD, the rectangular plane on the floor. So how do we approach this? We can draw vertical lines from point F to the line AB. Vertically under point F, there should be a point on line AB. And vertically under point E, there should be a point on the line DC. So let's call this point X. Let's call that point Y. And then this is the line that connects point X and Y. So we can see this cross section FEXY, which is rectangular. And if I draw a line from point X to point E, so you can see this line EX lies on the triangular plane AEB. So the line EX lies on the triangular plane AEB, and the line XY lies on the plane ABCD, the rectangular plane on the floor. The line XY lies on this plane. So if we can find the angle between the lines EX and XY, this angle here, we will be able to find the angle between the plane AEB and the plane ABCD. That's what we have to do. So right now we have to think about that triangle. the triangle EXY. So this is E, this is X, and this is Y. This is going to be a right triangle, and somehow we need to come up with this angle EXY. We can try and find the sides, EY, EX, or XY. Let's see what we can do. So let me redraw that triangle EXY here. So question C, we have triangle EXY, and we want to find angle EXY. So what do we know? Oh, we're given the angle. So the angle between the plane AEB and the plane ABCD is given. That is 65 degrees. So that angle is the angle between the line EX and XY. So this is 65 degrees. What do we need to do? We need to find in centimeters to two significant figures the length of EF. We need to find EF. Oh, and EF would be the same as XY. So basically, if we can find XY, we can find EF. So we know that this is 65 degrees. We want to find XY. Can we find EX or EY by using something else? Maybe we can calculate EY somehow. So let's think about the triangle AFB. Let me redraw the triangle AFB. So AFB, AB is 24 cm, AFB. We know all the angles. Angle A is 60 degrees, B is 45. 60 degrees, this is 45. And we want to find this line from F to X. This is point X, and this is 90 degrees. AX in all of that is 24 centimeters. So we already know the length of BF. We calculated the length BF in question B. It is 12 times 3 root 2 minus root 6. So we know this length, 12 times 3 root 2 minus root 6. So we don't even need the 24 centimeters anymore. So we can just use this triangle FXB to find the length fx. So we want to find fx. We have this. So basically, we want to find the opposite side for 45 degrees, and we know the hypotenuse. So we'll be using sine 45 degrees is equal to opposite side fx divided by the hypotenuse 12, 3 root 2 minus root 6. And we can find fx. Fx is equal to sine 45 times 12 times 3 root 2 minus root 6. 36. Okay, this is an exact value. 36 minus 12 root 3. That is fx. So in the diagram, we can see fx. The line fx is equal to the line ey. So we know the length ey. Therefore, ey is 36 minus 12 root 3. And if we can find xy, xy is equal to ef. So we'll be able to find ef. So let's find xy from using this triangle. So for angle 65 degrees, we know what opposite side is. We want to find the adjacent side xy. So we'll have to use tan. So tan 65 degrees is equal to opposite side 36 minus 12 root 3 divided by adjacent side xy. So xy is equal to 36 minus 12 root 3 over tan 65 degrees. Solve this to three significant figures at least. 7.095. That is xy, but since EF is equal to xy, EF is equal to 7.095, and if we round this to two significant figures, that is the first one, that's the second one. The next one is 9, so we have to round the second significant figure up. So it's going to be 7.1 cm. That's the length EF, 7.1 cm. Okay, question D. Find in degrees to one decimal place the size of the angle between the line CF and the plane ABCD. So the line CF and the plane ABCD. For that, we need this triangle. So we need this triangle, right triangle FXC. And since we want to find the angle between the line FC and the plane ABCD, we just need to find the angle between the line FC and the line XC. And that would be enough. So we already know the length fx? Yes, we do. 36 minus 12 root 3. Let me redraw that triangle for this part. So question D, triangle FXC. And we need to find this angle. We know the length fx, 36 minus 12 root 3. We need one more length, xc or fc. Let's have a look how we can find any one of those two lengths, fc or xc. We know ef. Do we know bf? Oh, yeah, we know ef, we know bf. So we can find fc. So if I look at the rectangular plane, fb, fe, ec, and bc. From there, we can find the diagonal fc. So we'll have to draw this rectangle, febc. febc, and we want to find the length fc from there. We know fe, it's 7.095. And then we know bf, or ec you can say, which was this, 12 times 3 root 2 minus 6. So we can find fc by using Pythagoras. So fc is the hypotenuse, so it'll be square root of 7.095, the whole squared, plus 12 times 3 root 2 minus root 6 within a bracket, the whole squared. Let's calculate this, 22.65. I'll just go with 22.657 cm. That's the length fc. So this is 22.657. That means we can find the angle FCX. So we are looking at opposite side and the hypotenuse. So we'll have to go with sine. Sine angle FCX is equal to 36 minus 12 root 3 divided by 22.657. So FCX is equal to the sine inverse of all of this. Let's calculate this. That is 42.18 degrees. So we want the answer in one decimal place. So 42.2 degrees. And that's the angle between the line CF and the plane ABCD. The line CF and the plane ABCD. 42.2 degrees. Angle between CF and the plane A, B, C, D. That's the end of question 9. Question 10. The points A, B, C, D are the vertices of a quadrilateral such that vector AB is equal to 3A plus 4B, vector AC is this, vector AD is that. Question A, show that ABCD is a parallelogram. So we need to show pairs of parallel sides. Okay, so let's just draw ABCD as a parallelogram and see how it looks like. So A, B, C, and D. So we know vector AB, that is 3A plus 4B. Vector AC, okay, that is different. That is this, 7A plus 9B. Okay, I'm not going to write that down over there. AD is this, 4A plus 5B. So what would vector DC look like? So if I just want to find an expression for vector DC, to go from point D to point C, I could go DA and then AC. So that could be negative AD plus vector AC. So we have an expression for AD. We have to put a negative sign in front. So negative 4A minus 5B plus vector AC. The expression for vector AC is 7A plus 9B. 7A plus 9B. And let's simplify this. So 7 minus 4A would be 3A. 9 minus 5B would be 4B. So 3A plus 4B. So that is vector DC, and that is exactly the same as vector AB. That shows vector AB and vector DC have equal lengths and are parallel as well. Okay, then we'll need to work out the value of vector BC to show the other pair of parallel sides and equal lengths. So vector BC, let's say we go from B to A, which is negative AB, then we go A to C, which is plus AC. Okay, so negative vector AB would be negative 3A minus 4b plus vector AC, which is 7a plus 9b. And let's simplify. So 7 minus 3 is 4a, 9 minus 4 is 5b. So 4a plus 5b, is it the same as vector AD? 4a plus 5b, yes, it is. It is exactly the same as vector AD. So we can see that AD is equal to BC, AB is equal to DC. Therefore, the quadrilateral ABCD is a parallelogram. Okay, we should actually specify that when AB is equal to DC, that also means that AB and DC are parallel. So let's just add another line just to be safe. If AB is equal to DC, vector AB is parallel to vector DC, and if vector AD and vector BC are equal, they're also parallel. So AD is parallel to BC. We should just add this just in case. So let's look at question B. So BC is extended to the point E such that BCE is a straight line. So BC will be extended. We don't know how long. So let's continue reading. Point F lies on CD such that CF to FD is 1 to 2. So point F lies on CD and CF is shorter, FD is longer. So let's say F is somewhere here. This is point F. And it's split in the ratio 1 to 2. So CF is 1, FD is 2. And then, given that A, F, and E are collinear, A, F, and E are collinear. Okay, so we need to draw a straight line from A to F, and we'll extend it, and point E will be here. So this is point E. So BC is extended to BE, AF is extended to AE. AF and E are collinear. Okay. Question B, find the vector AE, A to E, in the form XA plus YB, where X and Y are rational numbers to be found. So to do that, we need two different routes. So we can go from A to E. AE can be written as an extension of AF. Let's write that down. Vector AE is an extension of vector AF. So vector AF and vector AE are parallel. So we can say AE is equal to mu times vector AF, where this mu would be larger than 1 point something, showing that AE is longer than AF, but we don't know how much longer. Is there any other way of finding AE? Any other route to go from point A to point E? Yes, we can go A to B and then B to E. So AB plus BE. So AE can also be written as AB plus BE. Okay, what is BE? BE is an extension of BC. So we can say BE is lambda times BC, because BC and BE are parallel. So AB plus BE is an extension of BC, so lambda times BC. So we have two different ways of finding the vector AE. Let's write down their expression. So vector A is equal to mu times vector AF. What is vector AF? So AF is, we have to go from A to D first, which is 4A plus 5B. So that is vector AD, 4A plus 5B. Then, so we have traveled from A to D, and then we have to go from D to F. What is D to F? D to F is 2/3 of DC. So 2/3 of DC. What is DC now? So DC is the same as AB. AB is 3A plus 4B. So 2/3 of 3A plus 4B. And that is the expression for vector AE using vector AF. So AE is equal to mu times 4A plus 5B. 2 over 3 times 3 is just 2, so 2A plus 2 over 3 times 4 is 8 over 3B. Let's simplify this further. So AE is equal to mu times 4 plus 2 is 6, 6A plus 5 plus 8 over 3 is 23 over 3B. So that's an expression for AE. Let's do the same with this equation. So vector A is equal to AB plus lambda BC. So what is AB? AB is 3A plus 4B. So 3A plus 4B plus lambda times, what is BC? BC is 4A plus 5B. We can do this. So I'll rewrite AE on the left-hand side. AE is equal to 6 mu A plus 23 over 3 mu B. And on the right side, I'll group all the A vectors together. So that's going to be 3 plus 4 lambda A plus 4 plus 5 lambda B. So that's another expression for AE. So we have two equations for AE, vector AE. If these expressions are for the same vector AE, then we can equate the coefficients of A vector and the coefficients of B vector. So we can say 6 mu is equal to 3 plus 4 lambda. So 6 mu is equal to 3 plus 4 lambda. And we can also say 23 over 3 mu is equal to 4 plus 5 lambda. So 23 over 3 mu equals 4 plus 5 lambda. And let's solve these equations simultaneously. So how should we approach this? We can try and find mu by substituting lambda. Let's use this equation here and make lambda the subject. So we have 23 over 3 mu minus 4, and we'll divide all of these by 5 lambda. So lambda is equal to 23 over 5 times 3. So 23 over 15 mu minus 4 over 5. And we'll substitute this on the equation on left side. So therefore, 6 mu is equal to 3 plus 4. In place of lambda, we will substitute 23 over 15 mu minus 4 over 5. So 6 mu is equal to 3 plus 4 times 23 is 83 times 1, 92 over 15 mu minus 16 over 5. So let's move 92 over 15 to the other side. So 6 minus 92 over 15 is minus 2 over 15 mu. And on the right side, we have 3 minus 16 over 5, which is minus 1 over 5. Or we can say minus 3 over 15. We can multiply both sides by negative 15 so that we have 2 mu is equal to 3. So mu is equal to 3 over 2. That means mu is 1.5. Once we know the value of mu, we can just substitute over here in this expression to find the vector AE. Therefore, vector AE is equal to 6 mu A, so 6 times 1.5 A plus 23 over 3 mu B. 23 over 3 times 1.5 B. So what does this turn into? 6 times 1.5 gives us 9A. 23 over 3 times 1.5 gives us 11.5 B. That is vector AE. Since they have mentioned rational numbers, just to be safe, we should use fractions to make it explicit that it's a rational number. So instead of saying 11.5, we should use a fraction form, 23 over 2b. That is better. So the answer is vector AE equals 9a plus 23 over 2b. That is question 10. Question 11, using formulae from page 2, show that question A1, cos 2a is equal to 2 cos squared a minus 1. There's A1. So cos 2a. So let's have a look at the formulae. So we have cos 2a. We can split cos 2a into cos a plus a and apply this formula cos a cos b minus sine a sine b. So if we have cos a plus a, it is going to be cos a minus sine a sine a. So that's what we have to do. Let's go back. So cos 2a is equal to cos a plus a, and that would mean that we have cos a minus sine a sine a. And we would have cos squared a minus sine squared a. And what do we need to turn this into? We need to turn this into 2 cos squared a minus 1. So we have to get rid of sine squared a. We can recall an identity where sine squared a plus cos squared a is equal to 1. That means sine squared a, when made the subject, would be 1 minus cos squared a. So let's substitute that over here. So cos squared a minus, in place of sine squared a, we'd have 1 minus cos squared a. So this becomes cos squared a minus 1 plus cos squared a, and that is 2 cos squared a minus 1. And we have shown that is a1. Now a2, we need to show that sine 2a is equal to 2 sine a cos a. So sine 2a similarly can be written as sine a plus a. And sine a plus a would be sine a cos a plus cos a sine a. So if you look at these two terms, they're exactly the same. If you add them, it just becomes 2 sine a cos a. And we have shown this as well. That is a2. Now let's look at question B. Show that cos cubed a is equal to cos 3a plus 3 cos a over 4. So it's going to be similar. So let's say left-hand side is equal to cos cubed a. Now right-hand side is cos 3a plus 3 cos a over 4. Everything divided by 4. Now let's use this right-hand side to alter it into something that looks like left-hand side. So cos 3a can be turned into cos 2a plus a. And then we have this 3 cos a, and then divided by 4. Actually, we can move divided by 4 in front. We could just say 1 over 4 of all of this. So right-hand side continued would be 1 over 4, and cos 2a plus a would be cos 2a cos a minus sine 2a sine a, and we have this 3 cos a. Let's continue this. 1 over 4. So cos 2a, let's split this again. So cos 2a, we just saw earlier, is equal to 2 cos squared a minus 1. So this will be turned into 2 cos squared a minus 1. So we have dealt with this, but this needs to be multiplied to cos a. And then next, we have sine 2a, and it can be turned into 2 sine a cos a. So 2 sine a cos a. We still need to multiply this bracket with sine a. So sine a. And then we have plus 3 cos a. Let's continue. 1 over 4 bracket cos a multiplies into this. So 2 cos cubed a minus cos a. Now we have everything in terms of cos a. And then minus the second term. Let's multiply sine a into this, so that it becomes 2 sine squared a cos a. And then we have 3 cos a. Next, 1 over 4, 2 cos cubed a. Let's write that down. 2 cos cubed a. We have minus cos a plus 3 cos a, and that turns into plus 2 cos a. And then we have sine squared a. That can be turned into 1 minus cos squared a. So we have minus 2 cos a multiplied to 1 minus cos squared a. So we still need to deal with this term. So 1 over 4, we have 2 cos cubed a plus 2 cos a. Now minus 2 cos a multiplies with 1, so that's minus 2 cos a. And then minus 2 cos squared, minus 2 cos a multiplies with minus cos squared a, so that becomes plus 2 cos cubed a. And then let's simplify. So we have 2 cos cubed a, we have another 2 cos cubed a, and that becomes 4 cos cubed a. And then these two middle terms, 2 cos a minus 2 cos a, they cancel. So we only have this. And when it multiplies with 1 over 4, that becomes cos cubed a, and that is equal to left-hand side. So we've shown that left-hand side is equal to right-hand side. Yes. Question C. And then it says, hence or otherwise, solve giving exact values in terms of pi. But we need to solve this equation for theta values between 0 and 2 pi. Let's write the equation down. So between 0 and 2 pi, 8 cos cubed theta over 2. So 8 cos cubed theta over 2 minus 6 cos theta over 2 minus 1 is equal to 0. So the domain is for theta, and this domain will be different if we are solving for theta over 2. So if we do theta over 2, we have to divide 2 pi by 2 so that it becomes pi. If we divide 0 with 2, we just get 0. So that's a new domain for theta over 2. How do we solve this equation? It's a cubic equation. It's difficult to solve. So we need to think of a different way. We just saw that the question says hence or otherwise. That means the best thing to do is to use the answer obtained in B in part C. So if cos cube A is equal to this, cos cube theta over 2 can also be changed to something that does not have cube. So we had this cos cubed A equals cos 3a plus 3 cos a divided by 4. So if I want to replace cos cubed theta over 2, I can. So I'll just have to substitute this. So in place of a, I'll have to write theta over 2. So that turns into cos 3 theta over 2 plus, and by the way, 3 and theta over 2 are multiplied here, plus 3 cos theta over 2, everything divided by 4. I think it's 4. Did I write 2? Yeah, it's 4. It should be 4. Divided by 4. Okay, and then minus 6 cos theta over 2 minus 1 equals to 0. Let's simplify this. So 8 times 4 is 2. So we have 2 bracket cos 3 theta over 2 plus 3 cos theta over 2 minus 6 cos theta over 2 minus 1 equals to 0. Let's multiply 2 into this bracket, so it becomes 2 cos 3 theta over 2. And then 2 times 3 is 6 cos theta over 2. And then we have minus 6 cos theta over 2, and these two will cancel. Minus 1 equals 0. So finally we have 2 cos 3 theta over 2 minus 1 equals 0. That means we'll be solving 3 theta over 2. So we have to readjust our domain. So our domain would be 0 less than or equal to 3 theta over 2 less than or equal to, if we multiply 3 over 2 to 2, we will get 3. So 3 pi. So we'll be finding our answers from 0 to 3 pi. For 3 theta over 2. So how do we solve this? We'll move minus 1 to the other side, 2 to the other side, so it is cos 3 theta over 2 is equal to 1 divided by 2. Now we have to solve. Before we solve, we have to turn this into a reference angle. Instead of calling it 3 theta over 2, I'll be calling it a reference angle alpha. Cos alpha is equal to half. And this reference angle alpha, without using the calculator, we know that cos 60 degrees gives us half. In terms of radians, 60 degrees is 1/3 of 180. So that is pi over 3. So cos pi over 3 gives us half. The reference angle is pi over 3. So we can use the unit circle, and the quadrants are first, second, third, fourth, A, S, T, and C. Where do our solutions lie? So what are we trying to solve? We're trying to solve this one, where cos is a positive value. Where is cos positive in these quadrants? So it is positive here because all is positive here. All means sine, cos, tan, all of them are positive in this quadrant. So we have an answer in this quadrant. Do we have an answer in the second quadrant? No, only sine is positive there. Only tan is positive there. In the fourth quadrant, cos is positive. So we also have an answer in the fourth quadrant. Let's use our reference angle. We have placed reference angle in the first quadrant. We'll do the same in the fourth quadrant. Remember, the reference angle is the angle between the line and the x-axis, not between the line and the y-axis. It is always touching the x-axis. And we know the alpha value, that is pi over 3. Now we can start counting our answers. And we're allowed to go from 0 to 3 pi. So if we go from here to there, that is pi. Here to there, if we continue, that is 2 pi. And if we continue, that is 3 pi. So we can look for our answers up until 3 pi. So our first answer is this, which is pi over 3. Now we're replacing alpha with 3 theta over 2. So 3 theta over 2 could be pi over 3, or second answer could be this, which is pi over 3 less than 2 pi. That means 2 pi minus pi over 3. Or we're still allowed to go further. We have gone beyond 2 pi. So this is 2 pi plus pi over 3. And if we continue going further, we won't be finding any more solutions. So we can stop here. So our third answer is 2 pi plus pi over 3. So what are these? Pi over 3, the first answer. The second answer, what is 2 minus 1 over 3? That is 5 pi over 3. The third answer is 2 plus 1 over 3, which is 7 over 3. 7 pi over 3. And these are the solutions for 3 theta over 2. So the solutions for theta would be, we can multiply all of these solutions with 2 over 3. So this will be 2 pi. 2 over 3 times 5 over 3 is 10 over 9 pi. And then 2 over 3 times 7 over 3, 14 over 9 pi. Sorry, the first one is 2 over 9, because we'll be multiplying 2 over 3 with 1 over 3, which is 2 over 9. So these are our solutions: 2 over 9 pi, 10 over 9 pi, and 14 over 9 pi. And if we have a look at this, none of these exceed 2 pi radians, which is the domain for the original. The answer should only go from 0 to 2 pi. And yes, our answers are within 0 and 2 pi. There are 3 answers. So question D, use algebraic integration to find the exact value of this integral. So let's copy this down. Question D. Let's say the integral is I. The limits go from 0 to pi over 6. The expression is 4 cos cubed theta minus sine 2 theta. Goes from 0 to pi over 6. 4 cos cubed theta minus sine 2 theta with respect to theta. So to integrate this, we need to turn this cos cubed theta into the expression shown in question B, this one. So cos cubed theta will be turned into cos 3 theta plus 3 cos theta over 4. Oh, it's multiplied by 4, so we can just cancel the 4's. So this will just be cos 3 theta plus 3 cos theta, and then we have minus sine 2 theta with respect to theta. Let's integrate them. So we'll use square brackets. To integrate cos 3 theta, it'll turn into sine 3 theta, but it'll be divided by 3. 3 plus cos theta. When we integrate cos theta, we'll get sine theta. So 3 sine theta will divide it by 1, which is just 3 sine theta. And then when we integrate sine 2 theta, we will get cos 2 theta, but we'll also have a negative sign. So plus cos 2 theta, and we'll have to divide by 2. And that's it. We will need to apply the limits now, pi over 6 and 0. So the upper limit, if we apply the upper limit, we'll have sine 3 times pi over 6 would be pi over 2. So sine pi over 2 divided by 3 plus 3 sine pi over 6 plus cos 2 times pi over 6 would be cos pi over 3 divided by 2. That is the bracket for upper limit. Subtract. Now let's apply the lower limit values. The lower limit, it'll just be sine 0 over 3 plus 3 sine 0, and then plus cos 0 over 2. What does that turn into? So sine pi over 2. Sine pi over 2. Pi over 2 is 90. Sine 90 is 1 over 3. Plus, what is pi over 6? 180 divided by 6 is 30. So sine 30 is half. We get 3 over 2. And then plus pi over 3 is 60 degrees. 180 divided by 3 is 60. Cos 60 degrees is also half. So this will be 1 half times 1 half, 1 over 4. Then minus sine 0 is 0. 0 divided by 3 is just 0. Sine 0 is 0 again. And cos 0 is 1, so we have half. And finally, if we use our calculator, 1 over 3 plus 3 over 2 plus 1 over 4 and minus 1 over 2 gives us 19 over 12. 19 over 12. What's the question again? We just have to integrate it and find the value. To find the exact value is 19 over 12. That's the answer. Okay, so that's the end of June 2024 Edexcel International GCSE Further Pure Mathematics Paper 2 walkthrough. I hope this helps you understand not just the solutions, but the thinking behind them as well. If you found this useful, make sure to like the video and subscribe to Pinnacle Education for more IGCSE content. Feel free to drop any questions in the comments. I'm always happy to help. I'll see you in the next video.